To reach net zero carbon emissions, the aviation industry is transitioning towards more electric and connected aircraft.
One of the biggest challenges is the weight and complexity of the onboard wiring and power systems. The Horizon 2020 ADENEAS project has tackled this task by introducing wireless and powerline communication technologies, alongside advancements in cooling systems and power electronics. These new technologies significantly reduce the weight of the power and data networks in aircraft.
The ADENEAS concept employs a hybrid data network in which wiring is complemented with powerline communication and wireless communication. The most prominent challenges that wireless communication face are reliability and network capacity.
ADENEAS has aimed to reach the same level of reliability as a wired communication system by carefully trading off various technological solutions. Through testing and simulation, we have optimized the capacity and range of the wireless network and studied how the signals bounce around within a given space. Certain radio frequencies interfere with critical aircraft systems, such as the radio altimeter, which might cause unwanted risk. We investigated solutions to minimize this interference, like shielded passenger windows. Besides minimizing wiring through wireless communications, we can further reduce weight by transferring data via the powerline cables. The need for extra data cables will therefore be eliminated. This is called powerline communication.
Powerline communication uses power cables to transfer the data and can be used for equipment that is already connected to this power network.
ADENEAS performed comprehensive testing to make sure this system will not interfere with other electronic systems. This is done in NLR's electromagnetic compatibility facility and in a test aircraft, the Vector Sportstar EPOS.
To improve the efficiency and effectiveness of the power network, ADENEAS has focused on modular power electronics.
Together with new hardware development, this makes it possible to use smaller and more efficient power converters that provide power to corresponding devices when needed. As a result, there is a substantial weight reduction. More electric aircraft produce a lot of excess heat from its power electronics. Therefore, ADENEAS also needed to come up with a cooling system to combat this matter. We designed a lightweight two-phase cooling solution.
This solution takes advantage of evaporating cooling fluids, making them very efficient in terms of volume and weight. By means of Nanofeatures on the cooling channel wall, the heat transfer of the total cooling system can be further improved. The resulting cooling system is flexible and modular, hence can be adapted to any aircraft scenario.
The performance of the overall system have been tested and validated in a specialized thermal lab.
The Horizon 2020 ADENEAS project has proposed a safe and optimized power and data network that is scalable to various aircraft sizes.
All technologies are seamlessly merged within an automated, streamlined and efficient design process. Furthermore, ongoing efforts are being made towards the certification and standardization. ADENEAS technologies deliver a 456 kilogram weight reduction for a standard 120-seat aircraft, resulting in a 334 kilogram decrease in CO2 emissions per flight over 4,000 kilometers, advancing sustainable aviation.